Dear learner, welcome back. Can you recall what we discussed towards the end of the session on importing modules in Python? Yes, I introduced you to the concept of packages. Remember, we created a package called phone, wherein we had three different phone classes: POTS, ISDN and G3. Today, we will explore the concept of packages in more depth with some more examples. Recall how I defined a package. A package is a hierarchical directory file structure that defines a single Python application environment that consists of modules and sub-packages and sub-packages and so on. When you have got a large number of Python classes or modules, you will want to organize them into packages. When the number of modules, remember, a module might just be a file containing some classes in any project, grows significantly, it is always wiser to organize them into packages. That is, placing functionally similar modules or classes in the same directory. In this session, we will see how to create a Python package. Creating a package and working with it is very simple. All you need to do is first create a directory and give the directory a name. It is your package name. Put your classes or modules in it. Create a file named __init__.py in the directory. That is all. Wasn't that really easy? The file init_.py is necessary because with this file Python will know that this directory is in fact a Python package directory rather than an ordinary directory or folder. It is in this file where we will write some import statements to import classes from our newly created package. Now, let us go ahead and create a package called animals. This package will contain two module files, namely mammals.py and birds.py with classes mammals and birds respectively. In step 1, create a directory called animals. In step 2, now create a file called mammals.py in the animals directory with the content shown here. We have the class called mammals. So, a Python class as we have already seen before. So, here we have the constructor, and in that constructor we are initializing a list of some animal names which are mammals. For example, here we have taken three animals: tiger, elephant and wolf, and we have created a list, and that list is the property of this mammals class. And we have put another function called print members for printing out the members of that particular list, and for that we just use this print statement and a for loop for printing the items in the list, and that prints out the names of the animals. Okay. The code is very simple. The class has a property named members, which is a list of some mammals we are familiar with. It also has a method by the name print members, which simply prints the list of mammals in the class. Here is a caveat you should remember. In Python package, all classes must be capable of being imported. We will not be executing them directly. Similarly, create another class named birds in the same animals directory and fill the content of the birds.py with the content. Now, in this code you will see that we are now created a similar class as that of the mammals. Now, but now this time we call the class as birds. Similarly, we have a constructor. So, wherein we have a property called members, which is a list, and there is a list of 3 birds, okay, namely sparrow, crow and hen, which are initialized in the constructor. And like before, as we did in mammals, we have a print method, that is the print members, that prints the members of the list in birds. Okay. So, which has a for loop and a print statement. So, this code is almost similar to the previous code. As I said, this code is similar to that of the mammals class, except that the property now contains a list of birds we are interested in. In step 3, finally, we create a file named _init followed by _.py in the mammals directory, and put the code in for importing the classes mammals and birds. From mammals import mammals, from birds import birds. Now, we have completed creating a new package called animals. Let us now test our newly created package. In the same directory where animals directory is located, create a simple file named test.py and put the code into it. So, here what we are trying to do is we are trying to test our package that we have created called animals. So, here in this code you are going to see that we have an import statements, that is from animals I import mammals, and from animals I import birds. Then I create the object mammal and call the method print method. So, here you can find my mammal is actually an object which is equal to mammals, the constructor. Okay. So, here I am going to create an object or instantiate an object of the mammals class and going to assign it to my mammal. Now, from my mammal I call the print members function. So, what do you expect from this? This method will print the list of mammals what I have stored in my class. Similarly, I create an object of birds class and call the method of it. For example, here I create an object called my bird. My bird is equal to birds. So, this is the constructor, birds is a constructor. Now, that creates an object or instance of the class birds and assigns to my bird. Now, my bird, using my bird and the dot operator, I call the print members function. So, what do you think this function will do? This function will list the birds that I have stored in my bird class. So, in fact, this program is called the test.py, and this test.py is actually residing outside the animals directory. Okay. So, it is in the parent directory, and from there I am going, then I will execute this file. So, that we will see in a short while from now. Once again, let me reiterate what we discussed with an analogy. We do not usually store all our files in our computer in the same location, do we? We always use a well organized hierarchy of directories for easier access. Similarly, files are kept in the same directory. For example, we may keep all the songs in the music directory, for example. In the same way, Python has packages for directories and modules for files. As our application program grows larger in size with a lot of modules, we place modules in one package and different modules in different packages. This makes a project or a program easy to manage and conceptually clear. Similarly, as a directory can contain subdirectories and files, a Python package can have subpackages and modules. Shall we have a more practice with another example? Okay. Suppose that we are developing a game. You know that games are pretty complex applications in computer. Have a look at the figure for the possible overall organization of the game we have developed. So, here you see that we have I have shown in this slide, you can see that there is a tree structure I have shown with the game as the root, and the game has 3 children, that is, one is sound, image and level. You know, any computer game has images to be shown, has some sound to be say played, and the level of difficulty to be set. Okay. So, for that these classes that actually are concerned with playing the sound are put under the package sound. Those classes which are concerned with displaying the images and the animations are put under the package image, and those classes that are involved in selecting and setting the difficulty level are actually put in the level package. Now, here you can see that this is slightly complex than our previous example. So, here what we have is we have a package game, the game is called the package, within which we have the sound, image and level. These 3 are sub packages, and in addition to these 3 direct. So, here you can see these 3 are sub packages. In addition to that, you have the init.py file. Okay. So, this first file, this init.py is within the game directory, tells the Python that this game is a package, it is not an ordinary folder, it is a package. So, that is why we put the file init.py here. And similarly, for every sub package, for example, sound, I have for example here 3 classes: load, play and pause. So, that we have put it in the sound package, sub package. In addition to that, I also have the same init.py file again within the sub package of sound. Why this again I have to put this init.py? This init.py in the sub package of sound is necessary to tell the Python that this sound is again a sub package of the package game. Similarly, for image there are 3 classes: open, change and close. In addition to that, I have the init.py, and likewise for sub package level I have 3 classes: start, load and over, and this again we have another init.py file. So, this init.py file is necessary whenever we want to designate a directory or a folder as a package or sub package. That is, here we have a top level package called game. Within the game package we have 3 sub packages called sound, image and level. Each sub package has some relevant modules in it. Now, how will you import the start module in your application? Of course, by using the import statement as import game.level.start, because you know that the start module or the start class is in the level package, sub package. Now, if this module contains a function named select difficulty to set the level of difficulty, we use the full name to reference it. So, you have to put it as game.level.start.select_difficulty, and say for example, I choose 2 as the level of difficulty. If this construct seems lengthy, we can import the module without the package prefix as follows. Now, we can have another way of importing the module like what we saw before. From game.level import start. We can now call the function simply as start dot select difficulty of 2. Yet another way of importing just the required function or class or variable from a module within a package would be as follows: from game dot level dot start import select difficulty. Now, we can directly call this function select difficulty without using any class name or package name, select difficulty. Even though the last way of appears to be easier, this method is not recommended. Using full namespace avoids confusion and prevents two same identified names from colliding, which is another purpose of packages. That is all in packages. Now, let us do a quick wrap up. Packages in Python are meant to organize your project into a hierarchical structure, putting relevant files or modules under relevant package names. Physically, the package structure corresponds to directory structure in your file system. While importing packages, Python looks in the list of directories defined in this sys.path, similar as for module search path. Packages also help in resolving namespace collision, that is, we can have two or more classes with the same name which can be resolved using the package name where they reside. For example, say we have a class called book. An accountant may use the class name book for representing an account book, whereas a librarian may use the class book to represent a book for lending. We have a class, here we have a class name collision, two different classes with the same name book. If packages were properly used, the accountant will refer to his book as accounts.book and the librarian would call his book library.book. Thus, the conflict is resolved. So, as I already said, we are now in this packages directory. So, this is where actually assume that this is my home directory from where I am going to run my program. Now, within this package directory, I have created a directory called animals. So, why should I create this directory called animals? Because I am creating a package by the name animals. So, I have to physically create a directory called animals. Now, within this animal, remember what I said, I am going to put two classes, one for mammal and the other for bird. So, there are going to be two classes here, one mammal and other bird. So, in the mammal class, what is that I am going to display is, so in this mammal class, so I have a class called mammal with a constructor by the name init, as we have already seen all these things, and a property called members. And who are the members of a mammals class? Tiger, elephant and wolf. So, these are the members and these are assigned to a list called a property called members in the mammals class. And as I said before, we have a print member function that simply prints the members of this mammals class. Similarly, I have another class called birds. So, this birds class, you can just see what is the content of the birds class. It is similar to the mammals class, except here that the members is a list of birds going to be sparrow, crow and hen. And again the same, we have a print member function that prints the list. So, now so you are clear that we have first step, we have to create a directory called animals. Within that directory, I have to put the two classes, or in any case, if the program is a complex one, we can have many classes and many such packages. And what qualifies this animal directory as a package? So, as I said, this init.py. This is a special file that you have to put it. The file can be empty or you can put some initialization code. So, in our case this file is empty. Okay. So, here this file is underscore underscore init underscore underscore dot py. So, this file qualifies the directory animals as a package. Okay. So, this is what we have seen in this thing. Now, just go back, just before going back I will tell you what is the content of the init. So, in this case that underscore underscore init is actually a empty file in our case, but actually you can, there may be some initialization code written there. So, as far as package is concerned, I have created a package. I have created a package called animals with 2 classes birds and mammals. Now, I have to test it, is it not? So, I have to go to the parent directory of animals. Go to the, which is the parent directory? Parent directory is the package. Package is the parent directory of animals. So, here you see the animals package within the package directory. Now, here what is that I am going to have? I am going to have the function here I am going to test this animals. So, I have written a Python code here called test. So, test.py. So, I will show you what is that in the test.py. So, in the test.py here you can see that first thing you have to do is you have to import, okay, because that is why we have created a package. I am going to import the classes that are available in my package. So, what is the package name? The package name is animals. So, from animals what I want to import from animals dot mammals, that mammals is the module. From that I want to import the mammals class. Similarly, from animals package and the birds module I want to import the birds class. So, this imports from import statement you have to use what we just discussed in importing modules. After doing that, now simply instantiate the mammals class and storing the object in my mammal, and instantiate birds class and store that object in my bird, and once the objects my mammal and my bird are ready, simply call the print method for the members. So, print member functions. So, my mammal dot print members, my bird dot print members. Okay. Now, let me run this program and show you the result. So, what do you expect when you run this program? Wow. So, you see that this test program prints the members of the mammals class. So, what are they? Tiger, elephant and wolf. Similarly, it prints the members of the birds class. What are they? Sparrow, crow and hen. That is all. Okay. So, this is as simple as writing a code for creating a package. Hope you enjoyed this session. Thank you so much.